Okay, let's see. Let's pick a question. Any question? Let's pick this one, I guess. So, what does the problem, how does it look like? So, the problem's name, subtract the product and sum of digits of an integer. Okay. So, problem statement, that would be given an integer number n, that would be our integer number n. Return the difference between the product of its digits and the sum of its digits. So basically you can split such a problem in three parts. In this case it's kind of obvious. First one is your input is your number n, right? Secondly, you have to have a way of calculating the product of the digits of that number. So basically there is also a step in between, right? We can even, I guess, something like a small sketch is always a good thing to have. So first things first, we will have get all digits of number. Let's see, get all number digits, right? So we'll basically have I'm not sure even if this is the best case, but yeah, let's see. We'll have, for example, a digit that is 123. So we have 1, 2, 3. We have split them. And next thing would be to make the product. So basically we'll have a loop that will take each of those, right? And it will basically, we'll have some variable, for example, although this is not quite Pythonic, but let's keep it like that for now. We have product, and it will always take a number and just multiply that number by each subsequent digit. So in the end we will have a result for this step, for a product, and then we will have the same thing happening here as well for the sum, right? The second loop, this would be the sum. It will work more or less the same way, but we're not multiplying. Now we're gonna be doing a addition. And then at the end, so we basically have step 1, step 2 is this whole thing here, and step 3 would be just to have the difference between the product and the digit and the sum. So we'll have basically the product minus the sum. So a very useful thing when programming is basically going over those simple steps. First step would be trying to understand the issue, trying to see how the issue would look like, come up with, basically try to recognize all the different steps that will be handled. Even if the issue is very easy, it kind of helps to have either a mental map or actually start, like most good programmers, or maybe I wouldn't say good programmers, but it's a good practice to have a piece of paper on the side and to kind of sketch what you would be doing in your algorithm. And this is a very easy way to kind of mock up your plan of execution, kind of see on a more kind of pseudocode level if anything is missing. For example, if you have to reorder stuff, or maybe if you could actually achieve your goal easier. So when you have that, and in this case we kind of I'll try to come up with a better solution than just drawing stuff on paint, because it doesn't look nearly as good as I would imagine. In this case, we have kind of like we outlined our 3 steps, and now we can just go and do that. So after we are done with implementing, well, basically after we did our planning, we can do the implementing. After we are done with the implementing, there are a couple more steps that we can do to improve our algorithm for future cases where you would also have to come back and edit stuff or put new features. And generally, it is a very good idea, and it is always recommended to have what is called clean code. So code that is very that reveals your intentions. And if you see, for example, the function name is not a function that is like, I don't know, it's not the function def hix or def my cool function. No, the function is exactly as something like I mentioned. It is exactly designed to give you the intention of the intent of that function. It's basically its target, its goal, and in this case the function is called subtract product and sum, right? So makes sense. Let's start working on that. Let's see. We would need to have this integer split into separate digits. So what comes to mind is to just get the string representation of this. So let's see. Let's call it. And this is basically the thing that you would notice. One of the biggest time consumers is coming up with function names and variable names that actually make sense. So that kind of things, naming conventions that will help you out when you come back to look at the code or when you start reading through the finished code, to kind of make sure that you don't really have to pause a lot when thinking about previous implementations. So in this case, let's see, let's call it something like digits from int, and I will put it in a list. So from this thing, let's say we would have for each digit, well, actually you wouldn't even need that, I think. Let's quickly try something out, just because I'm not entirely sure how converting a digit or an integer to a string would look like. Let's open up some software, some online Python interpreter, and test it out. Let's see, string, and this is also a very valuable step. Just test out every step of the way. Don't really assume things. This is way easier than going back and trying to decipher what you did wrong when bugs start to appear. So if I don't really know exactly what I'm going to get, trying to get the digits out of an integer, I would basically find a way to test that before I move on. So let's see, 55, what would that give me? For example, the string from 55 would give me probably a string, I guess. I didn't. Okay, let's print it. Okay, for each, let's test out if it's really like a string. If it behaves like a string, for each digit from our converted, right? Our converted digit string. So for each digit from that converted string, print digit. And this is, I think this is just lacking. For each digit, yeah, it should work like this. Not, maybe it's a keyword. for each digit in, I'm sorry, there is no from in this case, I guess should be an in. Let's see. Let's try it again, assuming we already converted it. Okay, sorry, for each. Maybe it's another language that I'm thinking about. There is no for each. Okay. Anyway. For a digit in string, print the digit. So it behaves like a string would behave. It's basically a list of characters. So after you have converted the integer to a string, it will behave as a list of characters. In our case, we have our input n, our int. So we would basically we can just keep it in our mind that we can convert it. We don't really need to save it right now. We can just go on to our next step. So we know that this is basically default or baseline implementation that's supported by default. So we don't really need to touch on that. Let's go over our product. So our product, let's see, digits product, and as you can notice, naming. Digits product is equal to can I even like this? Isn't there some let's see, probably a math function. So there should be some pre-baked functionality of doing this product iter2s in Python product. Yes, so like we said, you could basically make your own implementation if you like. In this case, if other than I wouldn't imagine any other case other than you didn't know the library existed, or you were at an interview and the interviewer said no, you shouldn't use any libraries in this test, you have to code it yourself. But in this case, no real no real incentive not to use that. So let's do this product, and then we would do, now we need a list of basically in this case it's a range, but we just need a list of integers, right? So we know that we have our string, or we can convert our int to string. So from that string we can basically get an int out of each digit for digit in string in n. So basically this will convert our integer to a string. We can take each string, or basically each digit in this string, and convert it back to an int, right? But it will be a 3-digit integer representation of each digit. So it will be, for example, in our case here, 4, 5, 6, it would be a 4, an int out of this 4, and out of the 5, and out of the 6, all in a list. So basically this list should be consisting only of integers, of integer representations of each digit, and then we can basically run the prod function on top of that, right? So basically this should give us everything that we needed. I'm pretty sure something like sum, maybe not, why not? Let's see, Python math sum, probably even let's see, we have sum, return like a floating point sum. We don't really care about floating points at the beginning, or at least we were not given, we know that our input is an integer, so there wouldn't be any floating points, right? what I was thinking about was some edge cases, because these questions oftentimes come with some edge cases that you have to handle. For example, we would probably have to think about cases where we are not given anything here, or maybe, I don't know, an integer that is somewhat weird, but I'm not sure in this case that there are any other edge cases to think about. But always keep in mind, for edge cases, they will ask you most likely on the interviews as well, or they would kind of look for that. And a lot of the Leetcode questions, or at least the ones I've done, a lot of them seem to have a bunch of edge case coverage as well for the test. So just keep it in mind while programming. So let's get back to finding our sum function, which is not nowhere to be found here. Was I here? Was I the other way? No, I was here. Okay. Let's reject all and exit. And some numbers. As we can see, we have numbers. We can do a sum on them. Let's just test it, because I'm thinking, okay, maybe I can do this without it. No, nothing here says that I need the math. Yeah, it's a built-in. So nothing here says that I need the math library, but I'll just quickly do this, right? Sum. So we need sum out of a list. The list would be 1, 2, 3. So we should get 1, 2, 4. Let's get a 7 out of this, right? Let's see. Yes, and we got it. So it's very easy. Digits, sum, right? And we would basically do a sum out of the same thing, all the digits in a list. So for runtime efficiency or performance, you could always just store this result separately and just call it from there, from memory. You don't really need the processor to run 2 times, but I mean, in this case, we don't really, it's not nothing burger basically, right? So we have the sum, we have the product. Our last step is to just subtract. So you can basically return, and what do they want? The product minus, so the difference between the product and the sum. So we would have digits product minus digits sum, and basically this is our function, and we can Pythonize it, which means we can basically take this stuff and not really use any variables. I think in other ways other than just like something even more Pythonic than having, for example, this thing loop twice. But never mind. Let's think about our solution quickly. What do we have? And also, when you think about, like, when you start reflecting on your solution or your function and you start seeing that it's hard to read, this is kind of a sign that you didn't really properly name things, didn't really structure things. Maybe there is some duplication inside. Maybe you for example, I don't know, like you left too much space, so it kind of becomes weird when you look at it, because like, what is, like, why is this the very first thing, and like, why is there some other operation right before the end, and like it kind of breaks the flow, right? So this is the time when you would kind of start noticing these things. So let's see, we have our digits product, right? It does the product of a list out of digits, and these digits are basically from the string representation of our input. We have the sum for the digits, and kind of the same thing. We wouldn't, as you can see, there is some small bug. I just forgot that I was trying to import something that's not there. So I got rid of that now by kind of just reflecting on what I did so far. And yeah, the result, what they wanted the difference. We have the difference. Let's see, they usually provide some sample code or sample test cases. and you can kind of test your solutions with that before submitting. In our case, okay, I have a typo. Yeah, actually, before even looking at the results, let's just kind of see what they wanted, because the examples in this case super useful. They want you to product and to some things and to and then just subtract them. Okay, super easy. Let's run our code, see what they had for us in the test case. They only had 2, 3, 4. 2, 3, 4 should give us 15. Gave us 15 and they expected 15, right? Super easy. I don't know, 1, 1, 1. That would be a 1 minus 1 plus 1 plus 1, 1 minus 3 minus 2, right? Let's see. I mean, I don't see any reason why not, but that's the case, right? For example, I guess they don't want the comma. You shouldn't assume things when programming. You should definitely test things out in your head before, if you can, and then also run it, test it, verify based on what you are expecting. And I was expecting a -2 and got the -2, and the program was also, or their checker was also expecting a -2, and easy peasy. It looks like we got this question going or working. I don't really see anything else what I can do here, so I'm just gonna submit it. And they say it's a success. Faster than 85% of Python online submissions. I mean, this is something that's not always representative, because there is some variance between runs. Anyway, and yeah, it's even more efficient than 100% of submissions. So what we can do now, we know that our code works, and this is exactly the problem that we had with this Leetcode problem. Now let's try and just make it more Pythonic, right? So first thing first, we don't really need those variables. We can just substitute our placeholders with the actual code, with the actual execution of stuff. And of course we can run it like this. First verify it locally, then push it for the submission. I mean, it works the same. What can we do more? Can we get a sum that we can subtract from a product in the same loop? I don't think it's possible. You definitely first need to calculate the whole product and the whole sum before doing anything with them. On a mathematical level, if you are multiplying things, you cannot, I mean, you could possibly, no, it doesn't really. I mean, there's probably some weird way of mathematically optimizing things and then writing things that are faster, but then it wouldn't be really readable for anybody else looking at this and wondering why is it not just like a product minus a sum or something like that, right? Anyway, a good thing to know, not over engineering your problems or solutions is also a very, very valuable thing when it comes to good software engineering, because not even you, like nobody, but especially not even you, would like to get back to something that I mean, you wrote, and then you wouldn't have any idea why you did that. You would get angry at yourself, and you would just spend time kind of like worried about your solution, because it wouldn't really look sound. And maybe it's perfectly fine, but you would start adjusting things because you wouldn't really find any meaning in those decisions anymore. So yeah, keep it in mind. Even this looks a bit weird, but I mean, it's kind of like when you start programming in Python, when you had some experience already, I mean, this looks super easy. So let's submit, let us submit this problem or this solution. And as you can see, a bit less runtime, which is weird because it shouldn't be that the case. Like I said, there is some variation there. Don't worry about it. So yeah, this is our first the first Leetcode question that I got to solve for you guys. I hope you are taking notes on how a person that is working as a software developer would think about a problem like this. I hope you learned stuff. I hope you will get motivated to do some of those questions yourself. And yeah, let's get back in 2 days and solve another one. Until then, yeah, like a wise streamer once or says a lot, in the wise words of Bob Ross, happy painting and God bless.